In this question, there is a proton which is trapped in a cylindrical beam of electron which is moving with a speed of light approximately, and the radius of that beam is r, and that beam is carrying a current of I. We have to ignore any magnetic effect. So let us see that what is happening here. So you can see that there is a beam of electron. This is an electron cylindrical beam whose radius is r, and a current is flowing in this direction like that. So this cylinder is a beam of electron, and therefore it would be filled with electrons completely. Now let us see the cross section of the cylinder. So let us suppose that there is a proton which is trapped at this point, which is at this point at some time, and this beam is having electrons moving out of the surface. So we'll see that this is a solid cylinder and a solid uniformly charged cylinder. So we know that in a solid uniformly charged cylinder, the electric field would be like that because there is a negative charge, and therefore the force acting on the proton will be like that. Okay, now the proton will cross the central axis of the cylinder and will go at this point, and therefore the force will start to act like that. So this proton will oscillate about the axis of the cylinder due to the electric field of electrons. Now we know that in a uniformly charged infinitely long cylinder, let's suppose this is its charge and its charge density is rho. I am assuming the positive charge, that doesn't matter. So at this point you can see that if we draw a Gaussian surface like that, so this surface has a radius r, and let's suppose the length is L. So the Gauss law says that E dot ds integration will be equal to q inside by epsilon naught. Now ds is the curved surface area, you can see, and therefore the curved surface area limit will be 0 to 2 pi rl. So E into 2 pi rl will be equal to q inside, and q inside will be equal to rho into pi r square into L divided by epsilon naught. So cancelling this pi with pi, L with L, R with R, E inside the cylinder would be rho r by 2 epsilon naught. Okay, so this we have already studied in electrostatics. Now this is E, and the force acting on the proton will be E times of E, and this would be equal to m omega square r, where r is the instantaneous distance of the proton from the central axis. So E into rho r by 2 epsilon naught is equal to m omega square r, cancelling this r with r. So you can see that omega square is equal to E rho by 2 epsilon naught m, and omega will be under root of that. Now let us see that what is rho. So to find out this charge density, I have drawn this diagram. You can see that in this diagram, let us suppose that there is a small cylinder of, this is a very thin cylinder of length dt, and this cylinder has a volume. Let us write down the volume of this cylinder. So the volume, elemental volume of that cylinder was pi r square into dt. In fact, dt is the time. So let us suppose that this is dx. So volume, elemental volume will be pi r square into dx. Now the charge enclosed in this cylinder would be dq, and dq will be equal to rho dv. We can also say that dq is equal to I dt, because I is equal to dq by dt, and this is rho dv, where dv is pi r square into dx. Now you know that as electrons are moving with the speed of light, so we can say that in moving this distance dx, it would take dt time. So dx by dt will be equal to c. So dx is equal to c dt. So I dt is equal to rho pi r square into c dt, cancelling this dt. So rho is equal to I upon pi r square c. Now we have already written the omega. Omega was E rho by 2 epsilon naught m. So omega was under root of E rho by 2 epsilon naught m. So we can substitute the value of rho here. So it would be E I by pi r square c into 2 epsilon naught m, and this is 2 pi f. So f will be equal to 1 upon 2 pi. Taking r common, it would be E I by pi 2 pi c epsilon naught m. So you can see that this is 1 upon 2 pi r E I by under root 2 pi c epsilon naught m. So the correct answer is option number A. Now we move on the next question. In this question, you can see that there is a cylindrical metallic conductor which is hollow, and the current is flowing through its surface only. There is a small slit of width epsilon which is running parallel to the axis of the cylinder, and this small slit is on the surface of the cylinder. So it is given that epsilon is very less than r. So we have to find out the magnetic induction B due to this remaining cylinder at the axis. We know that for complete cylinder, B for complete cylinder inside it is 0 inside. We know that, and therefore we can say that 0 is equal to B1. Let us suppose that this is B1 and B due to slit is B2. I have assumed that B2 is a magnetic field on axis due to slit. I have assumed that. So the sum of these two will be 0, and therefore I can say the magnitude of B1 will be equal to magnitude of B2. So we just need to find out the magnetic field due to this small part. So if we say that this current is flowing through the surface only, and the surface, you can see that the surface has a length, cross-sectional length of the surface is 2 pi r, and this width E is also a part of its cross-sectional length. So I will use unitary method and I will say that from 2 pi r current flowing is I. From one length current will be I by 2 pi r, and from this slit length current will be flowing, let's suppose I dash. So I dash will be equal to I by 2 pi r into slit width. I hope you have understood this method. You can imagine and you can easily understand this method. So I am assuming this slit is as a negligible width slit, and therefore I am assuming it as an infinitely long wire. You can see. So for infinitely long wire, B is mu naught I upon 2 pi r. So if I substitute the value of I dash, so it would be mu naught I epsilon upon 4 pi square r square. So the correct answer will be option number C. Now we move on the next question. In this question, you can see that this is a circuit in which this inductance is connected in between, and this is a milliampere, which is a emitter, and it is given in the question that at t is equal to infinity, which is the long time after the switch has been closed, the current flowing through this emitter is equal to this is 20 milliampere. So I've already drawn the diagram of t is equal to infinite state. We know that in an inductive circuit at t is equal to infinity, the voltage across inductor gets 0 and inductor gets short circuited. So I've drawn this wire instead of this inductor. So you can see that this resistance, these two are in parallel, these two are in parallel. So this is the equivalent of this resistance is equal to 4R by 5, and equivalent of this resistance is 6R by 5, and the R equivalent of this circuit is 10R by 5, which is 2R, and therefore the total current I is equal to V upon 2R, and the current flowing from the upper branch I1 and from the lower branch I2. So we can use the current divider law, and we can see that to divide this current into these two resistances, we can take the ratio, which is 1:4. Now you can add up the ratio, which is 5, and you can divide this whole current by 5. So by dividing this current by 5, it would be V by 10R. Okay, so V by 10R is this one part which I have extracted by dividing the total current with this ratio, sum of the ratio. Now we can say that this I1 will be proportional to this resistance. Therefore, there would be 4 times of one part. One part of this current was V by 10R. So this would be 4V by 10R. Okay, so I1 is equal to 2V by 5R, and hence I2 will be equal to the current flowing through this resistance would be in the proportion of this ratio, the ratio of this resistance. So it would be 1. So the current flowing through that part would be 1R, V by 10R. Okay, so these are the currents. You can see that this is I2 and this is I1, and the current flowing through this one. Now these two are also in parallel. So let's suppose that the current flowing through this resistance is I3, and therefore we can say that I3 will be again you can take the ratio, which is 3:2, and you can add up the ratio. So again the one part would be equal to V by 10R, and from this resistance the current I3 will be in the proportional to this resistance. So we can directly use 2 into V by 10R. So I3 will be equal to V by 5R. Now this I3 is given as 20 milliampere. So we can say that V by R is 100 milliampere. Okay. Now in the second case, this situation is given in the question that it is asked that the reading of the emitter immediately after the key was closed. So at t is equal to 0, when we have just closed the switch, we know that inductor opens the circuit and it offers infinite resistance. So I have not drawn this inductor and I have drawn an open circuit. So you can see that these two will be in series, and the total voltage across these two resistances R and 3R would be V. So the current flowing through this one will be V by 4R. Now we know that V by R is 100. So V by 4R will be 100 by 4, which is 25 milliampere. So the correct option will be option number C. Now we move on the next question. In this question, it is given that a projectile is launched from the Earth's surface with a speed of 10 kilometers per second So this is a projectile which is launched with a speed of 10 kilometers per second. We have to find out the height to which it will rise. So let us suppose that this height is h. Now let us use the energy conservation. We know that the initial energy of this system, interaction energy, will be gmm with a negative sign divided by this radius r, radius of earth. And the final energy of this system would be minus of gmm by r plus h. We always know that on increasing the height of any object from Earth's surface, its potential energy always increases. So we can easily predict that final energy will be greater than the initial one, and therefore it would be gmm, which is common, and this is 1 by r minus 1 by r plus h. Okay, now this energy will be equal to the kinetic energy of the ball. So this is gmm and divided by r into r plus h, and it would be h, and this is equal to half mv square. So cancelling out this m with m, we also know that gm is equal to gr square. So I am replacing this gm with gr square divided by r into r plus h, and it is equal to v square by 2, where v is 10 to the power 4 meters per second. So v square would be 10 to the power 8 divided by 2. So we can cancel out this, and you can see that g into 2 divided by 10 raised to power 8 is equal to r by h plus 1. You can see that g into 2 divided by 10 raised to power 8 is equal to r by h plus 1, and here it would be 1 r also. Okay, so this is the equation, and we know that g is 9.8, and this is 2, this is 64 into 10 raised to power 5 meters, and this is 10 raised to power 8, and this is r by h minus 1. In fact, plus 1. So by solving this value, you will get h as 2.52 into 10 raised to power 4 kilometers approximately. Okay, so this is the final answer. Now we move, C option is the final answer. Now we move on the next question. In this question, you can see that there is a ball, small ball, which is released inside a large cylindrical vessel, which is filled with oil. Now there is a resistive force due to that oil filled in the vessel, and that resistive force we all know as viscosity, and this viscosity is proportional to the velocity of the ball. Now ball approaches the terminal velocity of 5 centimeters per second. So we have to find out the time in which the ball will reach 90% of its terminal velocity. So we know that when a ball is traveling in a liquid, then at any instant of time, mg is acting in the downward direction, buoyancy is acting in the upward direction, and viscous force is acting in the opposite direction of the velocity. I am supposing that ball is moving in the downward direction. So at any time t, the net force on the ball will be mg minus buoyancy minus viscosity, which will be, viscosity will be 6 pi neta rv, we all know, and that would be equal to ma. So A will be equal to g minus buoyancy by m minus 6 pi neta rv by m, and this is dv by dt. Now let us suppose that this term is some constant A and this term is some constant B. So dv by dt is equal to a minus bv. Okay, so dv divided by a minus bv is equal to dt, and integrating both the sides, you can see that the limit of velocity will be from 0 to v and time will be from 0 to t. So this is ln a minus bv, and the limit would be from 0 to v, and it would be equal to minus b into t. So if I substitute the limits, then it would be ln 1 minus bv by a, and this is equal to minus beta minus bt. Okay, what I've done, I've substituted the value of v first of all in this equation, minus I've substituted this value 0. So when I will substitute the value v, then the term would be ln a minus bv, and when I'll substitute the value 0, then the term would be ln a, and these two terms would have a negative sign between them, and therefore we can write it down as this one because log a minus log b is log a by v. So you can see that 1 minus bv by a is equal to e to the power minus bt, and therefore v is equal to a by b into 1 minus e to the power minus bt. This is the final expression of velocity at any time t. Now let us solve the question. This is the terminal velocity and it is given as 5. So we have to find out the time in which it will reach the 90% of its terminal velocity. So this is e to the power minus bt. So this is 9 by 10, which is 0.9 of vt, and this is vt. This is 1 minus e to the power minus bt. So cancelling out this with this, you can see that it is e to the power minus bt is equal to 1 by 10, and e to the power bt is equal to 10. So bt is equal to ln 10. So ln 10 will be 2.303 ln log 10, and you all know that log 10 is 1. So time will be 2.303 by beta. Now we have to find out the value of beta. So we know beta, in fact b, we know that b is 6 pi neta r by m. So b is equal to 6 pi neta r by m, which is the mass, and the value of a, which is this one, is g minus b by m, buoyancy by m. So this is g minus, or I can say that value of a is mg minus buoyancy by m. Now we know that terminal velocity is equal to a by b from this equation. So vt is given as 5, and this is equal to, this is 5 centimeters per second. So let us write it down in meters. So it would be minus 2, and this is equal to a by b. So a by b will be mg minus buoyancy divided by 6 pi neta r. Now in the question there is no such data is given for which we can calculate buoyancy. So let us assume the buoyancy, this buoyancy, to be 0. So you can see that 6 pi neta r by m will be equal to g by 5 into 10 raised to the power minus 2. So this is b, and therefore b will be equal to 2 into 10 raised to the power 2. Or you can assume g as 9.8 or 10. I have assumed 10. So the time would be 2.303 upon 2 into 10 raised to power 2. So it is 1.11, in fact 1.17 into 10 raised to power minus 2 and we have to find this time into milliseconds, so we can write it down as 11.7 milliseconds. Therefore, the correct answer will be option number D. Now we move on the next question. In this question, it is given that there is a point charge which is placed on the axis of this ring, and this ring has a radius r. Now this point charge is at a distance of del, and del tends to 0, which means that this charge is placed very closer to the ring. Now let us imagine a situation in which there is a cylinder, and this cylinder has a charge q placed at the center. Now when we write down the flux of this cylinder, then that flux is q by epsilon naught, and this q by epsilon naught is being shared between three surfaces. The two surfaces are the cross section surfaces, and the 1/3 surface is the curved surface. So we can see that the flux of 1 plus flux of 2 plus flux of 3 is q by epsilon naught, and out of that this flux of 1 and flux of 2 would be same because they are symmetric. So let us suppose that this is phi naught. So phi will be equal to 2 phi naught plus phi 3, which is the flux of curved surface. Now we know that if we surround this charge with another such ring just above this charge at a distance del, which is tending to 0, then we can see that those two rings are so close to each other so that the cylinder which is formed by those two rings has a negligible curved surface area, because this length is negligible. So therefore we can neglect this flux, and we can say that the phi naught will be phi by 2, and phi by 2 will be q by 2 epsilon naught. So the flux of any single ring is equal to q by 2 epsilon naught. So the correct answer will be option number C. Now we move on the next question. In this question, you can see that there are three small identical neutral spheres. Let us suppose that these are three spheres, and they are kept at the vertices of an equilateral triangle, whose side is L. This I have assumed. It is not mentioned in the question. And there is a huge ball which is isolated, and it is charged conducting sphere, and the center of that ball lies on the line perpendicular to the plane and passing through the centroid, which means that you can imagine a line which is coming out of this plane and passing through the centroid, and there is a huge big sphere which is made to contact with all of three of them. As a result of which, first of all, it is given that when it is made to contact with all of them, then the charge acquired by ball 1 and 2 is q1 and q2, and the charge acquired by the ball 3 is unknown, and we have to find out the charge acquired by ball 3. So first of all, let us assume that the voltage potential of the bigger sphere is V, and when that sphere touches the ball 1, let us suppose this is ball 1, then it acquires a charge of q1. So I am assuming that this ball has acquired the charge before these two balls. So we know that at the time when it is acquiring the charge, the potential of this ball will be, let's suppose that it is k q1 by r is the radius of this small ball, as well as the radius of that bigger sphere is capital R, and the charge on it is q, I have assumed, and this is equal to V, where V is the voltage of that bigger sphere. Now, due to this charge on this first sphere, the second sphere will also be experiencing some potential, and therefore the potential of the second sphere will be K Q1 by L. This is the potential due to this ball, plus KQ by R due to the bigger sphere, as well as the potential due to that self charge which is acquired by the second ball. It is KQ2 by small r, and this is also equal to V, because V is the potential of the bigger sphere, which will remain constant obviously because it is so big, so that its potential and charge will remain unchanged. This we have assumed. So this is equation 1, this is equation 2. The equation 3 will be K Q1 plus Q2 by L is the potential created by Q1 and Q2 on Q3, as well as KQ by R is the potential on that sphere due to the bigger sphere, plus the potential on that sphere due to self charge, which is KQ3 by R. That is also equal to V. This is equation number 3. Now to solve these equations, let us subtract equation 1 and 2. So we'll see that this is cancelled out and this is cancelled out. So this is Q1 by R minus Q1 by L plus Q2 by R. So this is Q1 by R minus this is Q1 by L, and that is equal to minus Q2 by R. Minus Q2 by R is equal to 0. So you can see that Q1 minus Q2 by R is equal to Q1 by L. This is first equation. In fact, this is third equation. Now let us see what happens when we subtract 2 and 3. So this 2 minus 3 will be, if we subtract these two equations, then these terms will cancel out, and this is Q1 by L plus Q2 by R. This is Q1 by L plus Q2 by R, small r, minus Q1 plus Q2 by L. This is minus Q1 plus Q2 by L, and this is Q3 by R. So minus Q3 by R is equal to 0. So you can see that Q1 by L will be cancelled out, and the term would be Q2 minus Q3 divided by R will be equal to Q2 by L. This is equation 4. Now if we divide these two, 3 divided by 4, then it would be Q1 minus Q2 divided by Q2 minus Q3, and that is equal to Q1 by Q2. So cross multiplying these two, so this is Q1 Q2 minus Q2 square is equal to Q1 Q2 minus Q1 Q3. So you can see that it is cancelled, and Q3 is hence equal to Q2 square by Q1. So the correct answer would be option number B. Okay, now we move on the next question. In this question, you can see that this is a potentiometer circuit and this is a load resistance. Initially it is given that the complete resistance of this potentiometer is equal to the load resistance, and they both are equal to R. Now it is mentioned in the question that if we suddenly double this load resistance, then what will be the effect on the voltage across this load. So first of all, let us assume the initial condition in which this half part will have a resistance of R by 2, and this half part will have a resistance of R by 2, and this will have a resistance of R. So this is the circuit, and you can see that R and R by 2 are in parallel, therefore they will be R by 3. So by voltage divider rule, you can find out this V2 as 2V by 5. You can apply the voltage divider rule. Now finally what happens that this load resistance is doubled, so it is this potentiometer remains same. So this is R by 2 and this is R by 2, and this load resistance is now 2R. Now you can see that this has a equivalent resistance of, you can see that this is 2 by 5R. 2R by 5. Now again, if you find out V2 dash, then by voltage divider rule, then this V2 dash will be equal to you can see that these are in a ratio of 5:4. So this V2 dash will be equal to 4V by 9. Okay, so if we divide V2 dash with V2, then it would be 4 by 9 divided by 2 by 5. So this factor is 10 by 9. So this voltage has changed by a factor of 10 by 9. So the correct answer is option number D. Now we move on the next question. In this question, you can see that there is a block A of mass 2 kg and it is connected with a spring and it is kept on a frictionless horizontal surface at rest. It is connected with a spring whose spring constant is 1200, and there is another block B whose mass is 1 kg, and B slides on this horizontal surface towards A with a speed of 6 meters per second. B strikes A and it sticks to it, which means this collision is completely inelastic. So we have to assume that the collision occurred at time t is equal to 0. So we have to find out the position of this block A as a function of time. So first of all, let us balance the momentum of the system, and it would be 1 into 6, and after the collision occurs, the combined mass would have combined system would have a mass of 3 kg, and its velocity will be v. So v will be equal to 2 meters per second. This is the velocity. Now we can find out the omega. Omega is under root k by m, and you can see that omega is k is 1200 and the combined mass of the system is 3. So this would be 20. And the third thing which is important, that in this SHM you can see that this is positive extreme, this is mean position, and this is negative extreme. So you can see that the SHM is starting from the mean position and the particle is going towards negative extreme. So the initial phase in this SHM is pi. So the equation of SHM would be some amplitude A into sine omega, which is 20t plus phase pi. So you can easily see that there would be a negative sign, and irrespective of the fact that we does not need to find out the amplitude, we can directly say that the answer would be option number D by watching this negative sign and this omega, which is 20. So this was the easiest way to solve this kind of question. Now we move on the next question. In this question, you can see that there are two plates and they both have a same area A, and there is a thin liquid film between these plates, and when we will try to pull these plates apart, then this type of meniscus would be formed. The angle of contact is given in the question as 0 in this case, and therefore this would be a semi-cylindrical meniscus. You can imagine that this liquid layer would be a cuboidal and this meniscus would be a semi-cylindrical meniscus. We always know that for cylindrical surfaces, excess pressure is equal to T by R. You know that. Therefore, we can say that for this surface, the pressure at point B, which is just inside, will be slightly less than the pressure at point A, and PB will be less than PA. So we can say that PB will be slightly less than PA, and PA is equal to P naught, which is atmospheric pressure. So PB will be equal to PA, which is P naught minus T by R, which is excess pressure. Now you can see that from outside there will be a pressure of P naught of air, and from inside the pressure is P naught minus T by R. So the inner pressure is less, so we have to apply some force F. So F upon area would be the difference of P naught and P naught minus T by R. So this is T by R. So the force which we will apply would be T into A by R. Now R is the radius, and the separation between these two is given as D. So radius would be D by 2, radius of this cylindrical film. So F would be equal to 2TA by D. So the correct option would be option number C. Now we move on the next question. In this question, there is a pipe which has some radius R and length L, and through that pipe a liquid of viscosity coefficient neta is flowing with a rate Q. It is given that initially the pressure had at inlet of the pipe is twice of the atmospheric pressure, and when the pressure head has become 4 times of the atmospheric pressure and the length of the pipe becomes 2L and radius becomes 2R, then we have to find out the rate of flow. So we know a formula for rate of flow through a cylindrical pipe as pi delta P into R to the power 4 upon 8 neta L. This we have already studied. So we know that in first case, this delta P will be pressure head is twice of P naught minus P naught. This is the delta P, and therefore it is pi P naught R to the power 4 upon 8 neta L. And in the second case, you can see that the pressure head is 4 times of P naught, therefore delta P will be 4 P naught minus P naught. So this is 3 P naught, and therefore Q dash will be equal to 3 pi P naught into 2R to the power 4 upon 8 neta into 2L. So you can see that this is 16, and 16 by 2 is 8, and 8 into 3 is 24. So Q dash is equal to 24 pi P naught into R to the power 4 by 8 neta L. So you can see that Q naught is equal to 24 of Q. So the correct option is option number A. Now we move on the next question. In this question, you can see that there is a uniform horizontal rod of Young's modulus gamma, and it is kept on a horizontal frictionless surface. Its cross-section area is A, and there is a force F which is applied on the cross-section of this rod, and this force is horizontal. So we have to find out the strain developed in the rod. Now first of all, we know that as this rod is kept on a horizontal frictionless surface, therefore the acceleration of this rod A will be F upon M. If we suppose that the mass of this rod is M, then acceleration will be F upon M. And therefore, let us suppose that there is a point, this one, which is at a distance of x from the last end, and at this point, let us suppose the tension is T. So we can say that this tension is MA, where M is the mass of this portion. Okay, so in fact, we can say that M is the mass of this portion, this one, because this tension is pushing this mass in the forward direction. Okay, so tension is MA. So the mass of this portion M can be calculated by unitary method, which is m by L into the length of this section, and the length of this section is L minus x. Okay, so T will be equal to m by L into L minus x into A, which is f by m. So T will be equal to f by L into L minus x. Now this is tension, and the stress developed will be T by A, which is f by AL into L minus x, and the strain will be equal to stress upon Young's modulus. So stress is F upon AL, and gamma is the Young's modulus, and this is L minus x. Now this strain, we are supposing that there is a small element whose width is dx, and due to this tension, this element is contracted by a length of dy, and its new length becomes dx minus dy. So this strain will be dy by dx, and it would be equal to f into L minus x upon AL gamma. Now dy is the contraction produced in this length dx, and therefore we can say that dy will be equal to f by AL gamma, f by AL gamma multiplied by L minus x into dx. Integrating both the sides, let us put the limit of dy, which is from 0 to delta L, and x would be from 0 to L. So it is delta L, and it is equal to, this is f by AL gamma, and delta x will be equal to, this integration of this term would be Lx minus x square by 2. The limit would be from 0 to L. So delta L will be equal to f upon AL gamma, and this would be L square by 2. So you can see that cancelling L with L, delta L by L is equal to f by 2A gamma. Okay, so this is the strain developed, and therefore the correct answer will be option number B. Now we move on the next question. In this question, you can see that there is a uniform ring, non-conducting ring. It has a total charge of Q distributed over its circumference. The radius of this ring is R, and there is a time dependent magnetic field which is perpendicular to the plane of this ring, like that. And this magnetic field is changing with the rate of dB by dt. We have to find out the electric field generated on this ring. So we will use the formula which we have studied in electromagnetic induction, that E dot dl is equal to minus of d phi by dt. So we know that in this case E and dl are always parallel to each other. We always consider dl along E, and therefore the angle between E and dl will be 0. The limit of dl will be 0 to 2 pi small r, and this is equal to, now we are concerned with magnitude only, so let us first of all use negative sign, then we will talk about magnitude. So this is d by dt of area, which is pi r square into b. So area is constant, so E into 2 pi r is equal to pi r square into dB by dt with a negative sign. So you can see that cancelling this r with r and pi with pi, E will be equal to 1 by 2 r into dB by dt. So if we are concerned only about the magnitude, then we can say that the magnitude of E will be plus 1 by 2 r dB by dt, which is option number C. Now we move on the next question. In this question, you can see that a DC EMF of 15 volts is applied across a LR circuit which has a inductance which is of 5 Henry and a resistance which is of 10 ohms. So the time constant of this circuit will be L by R, and it is 1 by 2. Now they are connected in series, and we have to find out the ratio of current developed in the circuit at t is equal to 0.5 seconds and t is equal to 1 seconds. So we know that in a charging LR circuit, the current is growing, and the current is equal to I naught into 1 minus e to the power minus t by tau. This is the equation of current, and I naught is the peak current which is at its peak in steady state, which is at t is equal to infinity. So I is equal to I naught 1 minus e to the power minus t by tau, which we have already written. Now first of all, let us find out the current I at t is equal to 0.5 seconds, half seconds. So it is I naught and 1 minus e to the power. So you can see that time is half and time constant is also half. So it would be e to the power minus 1. And therefore I at half seconds will be equal to I naught into 1 minus 1 by e. This is equation number 1. Now let us find out the current at 1 seconds. So current at 1 second will be I naught 1 minus e to the power minus 1 by time constant is half. So I at 1 seconds would be equal to I naught 1 minus e to the power minus 2. Okay, so I at 1 seconds will be equal to I naught into 1 minus 1 by e square, and it is I naught into e square minus 1 by e square. Now if you find out the ratio of these two currents, I of half upon I of 1, then you can see that this I naught would be cancelled out, and the ratio will be e minus 1 divided by e square minus 1 into e. So you can see this would be e upon e plus 1. So the correct option will be option number C. Now we move on the next question. In this question, you can see that there is an insulating rod. Let us draw the rod. And this insulating rod has a total charge of Q, which is distributed uniformly along its length. And its length is L, as well as this rod is pivoted at the middle point. Okay. Now it is being rotated with a frequency of F, and we have to find out the magnetic moment of this system. So let us find out the omega first of all, and omega will be 2 pi f. Now we know that for any kind of charge body, the ratio of angular momentum and magnetic moment, in fact m upon L, where m is the magnetic moment and L is the angular momentum. So the ratio of m upon L is q by 2m, where I will write down all the things that m is magnetic moment, L is angular momentum, m is mass, and q is charge. Okay, so m will be equal to q by 2m into L, and q is small q, mass is m, and angular momentum will be I omega, and I will be ml square by 12, and omega is 2 pi f. Cancelling this m with m, this 2 with 2, so it would be q L square pi f by 12. So the correct option will be option number A. Now we move on the next question. In this question, you can see that there is a big circular loop of radius capital R, and there is a small circular loop of radius small r. They are concentric, and we have to find out the mutual inductance coefficient of this system. So we always know, and it is also given that R is very, very less than R in this case. So what we can assume that if some current is flowing in this bigger ring, then we know that the magnetic field at the center would be mu naught I by 2r. So we can see that this assumption says that radius of the smaller ring is very, very smaller than capital R. Therefore, we can assume that the magnetic field which is at the center of the bigger ring is same through in the complete area enclosed by the smaller ring. So we are assuming that this complete area is almost negligible and this ring is almost concentrated at the center only. So by assuming this, we can find out the flux, which is mu naught I by 2r magnetic field multiplied by the area of the smaller ring, which is pi r square. And we can equate this flux to mi. So phi will be equal to, in fact, mu naught I pi r square by 2r will be equal to mi. So cancelling this I with I, m will be equal to mu naught pi r square by 2r. So this is the mutual inductance of this system, and you can see that it is proportional to r square by r. So the correct answer will be option number B. Now we move on the next question. In this question, it is given that the intensity of an electromagnetic wave is 477.9 watt per meter square, and we have to find out the amplitude of electric field and magnetic field. We know that the intensity is related with electric field by a formula of epsilon naught, half epsilon naught, E naught square into C, and it is also related with magnetic field as half B naught square by mu naught into C. Okay, so we know the value of epsilon naught as 8.85 into 10 raised to power minus 12. The value of C is 3 into 10 raised to power 8, and value of mu naught is 4 pi into 10 raised to power minus 7. So by using these data and these two formula, you can find out the value of E naught and B naught, and therefore the correct answer would be option number A, which you can find out easily by these two formula. Now we move on the next question. You can see that in this question it is given that the critical angle of incidence for TIR within a transparent medium which is placed in air is 45 degree. So we know that sine of critical angle is equal to 1 by mu, where 1 is the refractive index of air and mu is the refractive index of this medium. And this critical angle is equal to 45 degree. So we can say that mu will be equal to root 2. Now we have to find out the Brewster angle of this medium. So Brewster angle is tan inverse mu. So this is I Brewster. So Brewster angle will be tan inverse root 2. So tan inverse root 2 is approximately 54.74 degree. So the correct option will be option number A. In this question, you can see that there is a hydrogen atom which is in ground state and is equal to 1, and the magnetic field produced by the electrons which is revolving in the ground state is B naught at the center. Now this atom is excited to n is equal to 4, and if we are assuming that Bohr model is applicable, then which of the following option is correct? So first of all, let us find out the magnetic field at the center of the atom when the atom is excited to n is equal to 4. So we know that the magnetic field produced by a point charge which is moving with some velocity v is mu naught by 4 pi into q v sine theta by r square. Now we know that the velocity of revolving electron in Bohr's atomic orbit is proportional to this is z by n, and the radius is proportional to n square by z. So you can see that the proportionality of B would be on n to the power 5 and inverse of n to the power 5. You can see that if you substitute the value of r here, then it would be n to the power 4, and if you substitute the value of V, then it would be 1 upon n, and therefore it would be n to the power 5. Now if we substitute n is equal to 4, then B will be equal to B naught upon 4 to the power 5, which is obviously not 64, so A option is incorrect. Now the energy absorbed by the atom in going from n is equal to 1 to 4 is 12.75. This we always know. And the change in angular momentum. So the angular momentum in ground state is h upon 2 pi, and in fourth state is 4h upon 2 pi. So change will be 3h upon 2 pi. And assuming that this excited atom is again transiting in to ground state by a single jump of electron, and in this process photon will be emitted by the atom. So the recoil speed of the atom can be calculated. Let us suppose that this is atom and a photon is released. So the momentum of photon P is equal to the momentum of atom. So momentum of photon is E by C, and that is equal to mh into V of atom. V is the velocity. So V is equal to E by C mh. Now we know that E is 12.75 into 10 raised to power minus 19 into 1.6 in joules, and C is 3 into 10 raised to power 8, and mh is given as 1.67 into 10 raised to power minus 27. So this would be nearly 4.1 meters per second, recoil speed of atom. So the correct answer would be B, C and D. Now we move on the next question. In this question, you can see that there is an experiment which is used to study the photoelectric effect. And in this experiment, a point source of light whose power is 3.2 milliwatt is used. This source emits monoenergetic photons of energy 5 eV, and it is located at a distance of 0.8 meters. From a point from a center of a stationary metallic sphere of work function 3. The radius of a sphere is 8 mm, and we have to assume that sphere is isolated and photoelectrons are instantaneously swept away from the sphere after emission. And we have to assume that the quantum efficiency is 10 raised to power 6, which means that every 10 raised to power 6 photons, 1 of 10 raised to power 6 photons ejects 1 electron. So we have to choose the correct options. So the first option is the de Broglie wavelength of the fastest electron is 8.7 angstrom. So we know that h nu is equal to W naught plus half mv square max. This formula we know. That now you can see that the energy of the photon is 5 eV. This is 5, and work function is 3 eV plus kinetic energy of the fastest electron is 2 eV, which means that this electron is having an accelerating potential as 2 volts. So we can directly find out its wavelength, which would be 12.27 upon under root V. So V is 2, so lambda is 12.27 by root 2 angstroms. So it is approximately 8.7 angstroms. So option number A is correct. Now option number B says that it is observed that after some time of the emission of photoelectrons from the surface of the metal, the emission stops, and the charge at that instant when emission stops is 64 pi epsilon naught into 10 raised to power minus 3 coulomb on sphere. So what is happening here, that when this sphere is emitting photoelectrons, then a positive charge is getting accumulated on its surface, due to which a potential is developed on the surface of the sphere, which is kq by r. Now when this potential will be equal to the stopping potential, which is 2 volts, we have already calculated stopping potential. So when this potential is equal to the potential of 2 volts, then the photo emission would stop, because these electrons would not have sufficient energy to escape the electrostatic field of the sphere. So by this we can say that Q will be equal to R into 4 pi epsilon naught into 2. Now Q is equal to R, where R is the radius of a sphere, which is 8 mm. So it is 8 into 10 raised to power minus 3. And this is 8 pi epsilon naught. Okay, so you can see that this is 64 pi epsilon naught into 10 raised to power minus 3. So option number B is also correct. Now we can find out option number C, that the time after which photoelectric emission stops. So let us see that the power which is emitted by the source is equal to 3.2 milliwatt. This is power. So you can see that power emitted is 3.2 into 10 raised to power minus 3 watts. And we can say that this power has a intensity I on the sphere, and this intensity would be power emitted divided by 4 pi d square, where d is the distance between source and the sphere. Okay, so you can also see that this d is in meters and this is in mm, so we can neglect the radius here, and therefore the intensity which is incident on the sphere is this one. Now you can also see that the power absorbed by the sphere would be intensity incident on the sphere into its area of a sphere. So power absorbed by the sphere would be power emitted divided by 4 pi d square, and into the area of the sphere is 4 pi r square. So power absorbed would be power emitted into r square by d square. Now we have to find out the number of photons. Let us suppose that this is the number of photons emitted per second. So to find out this number of photons emitted per second, in fact the number of photons absorbed by the sphere per second, let us write absorbed. So N would be equal to the power absorbed divided by energy of one photon. You can easily imagine that if, let's suppose, the energy of one photon is 10 eV and 100 photons are incident per second on the sphere, then power would be 10 into 100. So power is always the number of photons incident into energy of one photon. Now here we are talking about the power absorbed and number of photons absorbed. So the number of photons absorbed would be power absorbed upon the energy of one photon. And the power absorbed is P emitted into R square divided by D square, divided by the energy of one photon, which was, I guess, this was 5 eV. Okay, so this is 5 into E in joules, obviously. Now N is equal to, this is N, number of photons absorbed per second. Now we know that 1 out of 10 raised to power 6 photons, you can see that it is given in the question that efficiency of photoelectric emission is 1 for every 10 raised to power 6 photons, which means that 1 photon out of 10 raised to power 6 photons will emit photoelectrons. So if this is the number of photons absorbed, then the number of electrons emitted per second. Let us suppose that N is the number of electrons emitted per second, then this number n, small n, will be equal to the total number of photons absorbed upon 10 raised to power 6. Okay, because if n number of photons are absorbed, then only a fraction which is n upon 10 raised to power 6 will be the number of electrons emitted per second. So in t time, the total electrons emitted will be n into t. So it would be n upon 10 raised to power 6 into t. And this total number of electrons, if we multiply the total charge q, which is emitted by the sphere, will be negative charge which is emitted will be total number of electrons emitted into E, charge of one electron. And this is 64 pi epsilon naught into 10 raised to power minus 3. Okay, so let us insert a new page, that n upon 10 raised to power 6 into t into E is equal to 64 pi epsilon naught into 10 raised to power minus 3. So t will be equal to 64 pi epsilon naught into 10 raised to power minus 3 divided by E divided by n and into 10 raised to power 6. Now n, we know that n was this one. N was power emitted into r square, divided by d square into 5 into E. So time will be equal to 64 pi epsilon naught into 10 raised to power 3 divided by E and divided by power emitted into r square into d square into 5 into E, cancelling this E with E. So we know that d is equal to 0.8 meter, r is equal to 8 mm. The data is given in the question, and power emitted in this case is 3.2 into 10 raised to power minus 3 watt. And if we know that epsilon naught has a value of 8.85 into 10 raised to power minus 12, or instead you can do one thing, that you can write down the value of 4 pi. You can see, you can extract 4 pi epsilon naught. So the value of 4 pi epsilon naught will be equal to 1 upon 9 into 10 raised to power 9, which is 1 upon k. So if you will substitute all these values here, then the time will be approximately equal to 111 seconds. So answer C is correct, and it would be approximately 111 seconds. Now option number D, which says that light source emits nearly 4 into 10 raised to power 15 photons per second. So the number of photons emitted per second, we can calculate the number of photons emitted per second will be equal to the power emitted divided by energy of one photon. So the power emitted is 3.2 into 10 raised to power minus 3, in fact minus 3, yes. And energy of one photon is 5 eV, which is 5 into 1.6 into 10 raised to power minus 19. So you can see that this is 2, and 2 by 5 is 0.4, and this is 10 raised to power 16, and this is 4 into 10 raised to power 15. So answer option D is also correct. Now we move on the next question. In this question, you can see that there are two Carnot cycles and Carnot engines which are operating between same maximum and minimum temperatures of T1 and T2. their initial volume is same, which is Va, and then this cycle represents the different stages. It is given that Vc by Va is E cube, where E is the exponential and T1 by T2 is E, and engine 1 is having a monatomic gas while engine 2 will have a diatomic gas. So you can see that as these gases are different, therefore we can only say that the initial volume, which is Va, will be same, and further on the volumes would be different because these two gases are different. So first of all, let us assume that Va is equal to V. So V is same for all of them, and in the first process, which is this one, in isothermal expansion, it is given that T1 by T2 is equal to E, and it is also given that Vc by Va is equal to E cube. So you can say that in the process BC, process B to C, this is a adiabatic expansion process. So in adiabatic expansion, the equation is T1 V1 to the power gamma minus 1 is equal to T2 V2 to the power gamma minus 1. Okay, so the temperature at point B is T1 and temperature at point C is T2. So T1 into volume at point B is Vb to the power gamma minus 1 is equal to T2, and volume at point C is Vc to the power gamma minus 1. Now this T1 by T2 is equal to E, so E is equal to Vc by Vb to the power gamma minus 1, where we can substitute the Vc as E cube into V by this relation and this relation. So Vc is E cube into V. So E is equal to, this is E cube into V divided by Vb whole to the power gamma minus 1. Okay. Now we know that I am writing it down again, that E is equal to E cube, and this is V by Vb whole to the power gamma minus 1. Okay, now you can see that Vb to the power gamma minus 1 is equal to E into 3, E to the power 3 into gamma minus 1 and multiplied by V to the power gamma minus 1 divided by this E. So you can see that Vb is equal to E to the power, this is 3 gamma minus 4 divided by gamma minus 1, and this is multiplied by V. So for gas 1, which is a monoatomic gas, so it is a monoatomic gas, monoatomic. So for a monoatomic gas, gamma is equal to 5 by 3. You can easily find out the gamma by the formula 1 plus 2 by F, where F is the degree of freedom. So F is 3 for monoatomic gas. So Vb for monoatomic gas, Vb1 will be E to the power, this is 3 into 5 by 3 minus 4 divided by 5 by 3 minus 1 into V. So Vb1 will be equal to, so this is equal to 5 minus 4 and divided by, this is 2 by 3. So 5 minus 4 is 1 and 2 by 3 is in denominator. So it is E to the power 3 by 2, okay, into V. And for second gas, gas 2, which is a diatomic gas. So for diatomic gas, you know that gamma is equal, F degree of freedom for diatomic gas is equal to 5, and therefore gamma is equal to 7 by 5. So VB2 is equal to e to the power 3 into 7 by 5 minus 4 divided by 7 by 5 minus 1 into V. So you can see that this is 21 by 5 and minus 4, so it is 1 by 5, and in the denominator it would be 2 by 5. So you can see that VB2 will be equal to e to the power 2, in fact e to the power 1 by 2 into V. So if we find out VB1 upon VB2, then it is e to the power 3 by 2 upon e to the power 1 by 2. So it would be equal to E. So option number A is correct one. Now we have to find out the efficiency and work done. So first of all, let us talk about the efficiency. That we know that efficiency is 1 minus T sink by T source. So you know that for these both engines, T sink and T source are same. In fact, you can see that the higher temperature is T1 and lower is T2. This is the lower temperature. So we can say that T1 is T source and T2 is T sink, which is constant for both of them. So neta 1 will be equal to neta 2, and therefore this option D will be correct. Now we have to find out the work done. So you can easily find out the work done by using the trick that neta is equal to work done upon heat supplied. And you know that neta is same. So work done will be neta into Q supplied. So work done W1 by W2 will be equal to neta 1 by neta 2, which is same. So Q supplied 1 upon Q supplied 2. We always know in Carnot engine that heat is supplied only in the process AB, which is isothermal expansion. So in no other process heat is being supplied to the system. So we just need to calculate the heat supplied in this process. So in this process, you can see in isothermal expansion, heat supplied, in fact, first of all, delta U is equal to 0. So work done is equal to heat supplied, and work done, which is heat supplied, is nRT into ln V final by V initial. Now V final in this case is VB and V initial is V, which is VA. You can see that V final is VB and V initial is VA. So if we find out Q supplied 1 by Q supplied 2, then it would be T1 upon T2. Obviously temperatures, T1 is same for both of them, so T1 would be cancelled out. So it would be ln VB by V upon ln VB2 by V. Now we know that this equation says that VB, this is VB, in fact we have to find out W1 by W2, so VB1 divided by V is e to the power 3 by 2 and VB2 divided by V is e to the power 1 by 2. So this is ln e to the power 3 by 2 and this is ln e to the power 1 by 2. So you can see that ln e is 1 and this is 3 by 2 upon 1 by 2. So it is equal to 3. So work done W1 upon W2 will be equal to 3. So the correct option will be option number B. Now we move on the next question. In this question, you can see that there is a roller arrangement there is a roller whose radius is R is 2 centimeters, and there are two plates A and B which are on the either sides of the roller. The plate A has a velocity of 18 meters per second in the forward direction, v1 is equal to 18, but its acceleration is in the backward direction, which is 30. Plate B has a velocity of 6 in the forward direction and its acceleration in the backward direction, which is 8. So you can see that let us first of all assume that this ball has a velocity v and there is a omega in clockwise sense. So we know that at this contact point the velocity of this plate and the ball would be same. So let us assume that the velocity of this point is also equal to 18 and the velocity of this point is also equal to 6. So we can say that v plus 2 omega is equal to 18 and v minus 2 omega is equal to 6. So this is 2v is equal to 24 and v is equal to 12, while omega is equal to 3. So you can see that option number A is correct and option number C is correct. Now we also discuss about this accelerations. So let us draw a new diagram. You can see that this plate A is retarding in the forward direction, which means it is accelerating in the backward direction with the acceleration of 30. So we can say that the friction would be acting on this plate in the backward direction. And on this plate, friction will again be acting in the backward direction because it is also accelerating in the backward direction with acceleration of 8. So on this roller, the friction would be acting in the forward direction like that. Therefore, we can assume that A is in forward direction. We can also see that the retardation of this plate is greater than the retardation of this plate. So this friction would be F1 would be greater than F2. We can estimate. So that bigger torque would be of this force. Therefore, let us assume that alpha is like that. So we can again say that at this point the net acceleration of this point will be 30 in the backward direction and of this point should be 8 in the backward direction. Okay, because we know that at contact points accelerations should also be same. So we can say that A plus R alpha, which is 2, R is 2. So the acceleration of this point will be A plus 2 alpha, that is equal to minus 30, and the acceleration of this point will be like that. This is R alpha in the backward and A in the forward. So 2 alpha minus A will be equal to 8. So adding these two, this is 4 alpha is equal to minus 22 and alpha is equal to minus 11 by 2. And A will be equal to minus 19, you can see that. If you will substitute this value here, then 2 will be cancelled out and this would be minus 11 and here it would go and it would be minus 19. So none of the option is matching. So the correct options are only A and C. Now we move on the next question. In this question, you can see that there is a long rod of length L and mass M. It is pivoted at point O and initially it is in vertical position. The pivot is frictionless and the rod is released from this position and then it fall off, and we have to find out the following things at the instant when a rod becomes horizontal. So first of all, let us find out the angular speed, and for that let us use the law of conservation of energy. We know that when rod will fall off 90 degree, then the center of mass of the rod will descend down by a length of L by 2. So work done by mg in this case will be equal to mg L by 2. Now this work done will be equal to the kinetic energy of the rod And we can say that this point O is IAR, and the motion of the rod will be completely rotational about IAR. So when we will write the kinetic energy, so we can write only the rotational kinetic energy, which is half I along IAR into omega square. So we can equate these two, and we can write that mgl by 2 will be equal to half I about IAR will be equal to ml square by 3, and this is omega square. So you can say that omega will be under root 3g by L. So option number A is correct. Now the magnitude of angular acceleration at this position will be, so we can say that mg would be acting in the downward direction, and any hinge force acting will be along the hinge, and therefore the torque about hinge will be only due to the mg. So torque about hinge will be mg into L by 2, and that would be equal to I alpha, and I about hinge will be ml square by 3 into alpha. So alpha will be equal to 3g by 2l. So option number 2 is also correct. Now option number 3 says that the center of mass will be accelerating in the downward j direction. This is incorrect, because you can see that there would be two accelerations of center of mass. One would be tangential. So this tangential acceleration would be minus 3g by 4, but there will be a centripetal acceleration also, because center of mass is rotating in a circle. So this centripetal acceleration will be present, and therefore the net acceleration will not be this one. And the reaction force will be mg by 4. So this reaction force will be vertical reaction force, which would be mg by 4 j cap. But there would be a reaction force RH, horizontal reaction force, due to which this centripetal acceleration would be generated. So the reaction force alone will not be mg by 4. In fact, it would be the resultant reaction force due to these two forces. So option C and D are incorrect, and therefore the only correct options are A and B. Now we move on the next question. In this question, you can see that there are four mediums of thickness A1, A2, A3 and A4. And there are three rays, this ray and this one and this one. It is given that the refractive index N1 is 2.7 and the refractive index N2 is 2.43. And it is also mentioned in the question that this distance B is same, and B is 10 mm. And it is also given that the time taken by this ray to reach from A1 to B2, the time taken by this ray to reach from A2 to B3, and the time taken by this ray to reach from A3 to B4 is same. So let us first of all use all the given conditions, and you can see that, let us suppose if this is angle I1, this is angle I2 and this is angle I3, they all are the angle of TIR, which is the critical angle. Okay, now we can say that sine I1, in this case, let us suppose that this distance is x1 and this is x2 and this is x3. So we can say that sine I1 will be equal to perpendicular upon hypotenuse, which is b by x1. So x1 sine I1, and in fact we can write down the sine I1 as critical angle. We know that sine theta is 1 upon mu relative. So mu sine theta will be equal to n2 by n1. This is sine I1. So this is the first equation. We can say that x1 is equal to b n1 by n2. Okay, so you can find out the value of b in fact x1, which is b is 10 mm and n1 is 2.7 and n2 is 2.43. So in this way we can find out x1. This is equation 1. Now again using the same thing in the second TIR, we can say that sin I2 will be equal to n3 by n2. In fact n3 by n2, and it would be equal to b by x2. Now again we know the value of n2, so you can see that n3 will be equal to b by x2 into m2, which is 2.43. This is equation number 2. And b is also given as 10 mm, so let us write down b as 10. Now in the third case we can say that sin I3 will be equal to n4 by n3, and that would be equal to b by x3. So again it is 10 by x3, and you can use this equation as n4 by n3, and n4 by n3 is equal to 10 by x3. This is equation number 3. It is also mentioned in the question that the time taken by these waves to travel from A1 to B2, A2 to B3 and A3 to B4 is same, and the time will be equal to this distance upon the speed. So I can say that x1 by v1 is equal to x2 by v2 is equal to x3 by v3, and we know that v in a medium is c by mu, because mu is equal to c by v. So we can say that v1, we can write v1 as c by mu1, so it would be x1 n1, and it is equal to x2 n2, and it is equal to x3 n3. Okay, so you can again use this. You can see that n1 is given to us and x1 we have already calculated. So this x1 n1 we have already calculated, and x2 n2 we have a equation here, and in which you can see that there is a variable here. It is n4 n3 10 and x3, and here it is x2 n2, and that is equal to this one, and n2 is also given in the question, so we can find out x2 from this one. And in the third case you can see that x3 n3 is equal to this product which we have already calculated. So we have already calculated this value of x2, and we can substitute this value here and we can find out n3, and if we will find out n3, then we can find out x3 from this one. Okay, so after finding out x3 and n3, we can calculate n4. So these all values can be calculated, and to find out a1 and a2, this is a1 and this is a2 and this is a3, you can see that a1 will be equal to x1 cos I1, a2 will be equal to x2 cos I2. I can write it down as a1 will be equal to x1 cos I1, a2 is equal to x2 cos I2, and a3 is equal to x3 cos I3. Okay, so the value of cos I1 can be written as under root of 1 minus sine square I1, which we have already calculated previously, and this is x2 into under root of 1 minus sine square I2, and this is x3 into under root of 1 minus sine square I3. So this is a calculative part, and you can calculate on it on your own, and you can find out these values, and you will find that the correct options would be A, B, C and D. Okay, so you can use significant figures. You have to report the answers in 4 significant figures. So you can see that all of them are in 4 significant figures. So this is the correct answer, ABCD. Now we move on the next question. In this question, you can see that there is a asteroid which is isolated with any of the other mass in the universe, and it has a uniform mass density of rho. There is a spherical cavity along the diameter of this asteroid in such a way that the diameter of this cavity is equal to the radius of asteroid, which is r, and C is the center of asteroid. Now a ball of some mass is dropped from this point, and we have to find out the different physical quantities like speed and time and acceleration of the ball inside this free space cavity. So let us first of all discuss that what is the gravitational field inside the cavity. And we all know that the gravitational field inside the cavity is constant always. And this gravitational field can be easily derived by the formula that this is, we know already that in electrostatic, the electric field was rho. We can write the electric field. We can use the analogy of electrostatic, that electric field inside the cavity was rho A by 3 epsilon naught, where A was the distance between the centers of the sphere and the cavity. So this is rho, and this distance is equal to r by 2. So this is r by 6 epsilon naught. And if we wish to convert this formula into gravitational field intensity, which is an analogous quantity in gravity to electric field, so we can write rho in terms of rho and r in the place of r and 6. And by comparing k, which is 1 upon 4 pi epsilon naught, with g, we can write epsilon naught as 1 upon 4 pi g. So I is 1 upon 4 pi g. So I will be equal to 2 by 3 rho r g into pi. This is the value of gravitational field intensity inside the cavity, which is towards the center of the sphere, like that. And this is constant throughout. Now, if this is constant, then the potential difference between A and C can be easily written as 2 by 3 rho into r g pi into r. Because we know that if we move some distance r in a constant electric field, then the potential changes by a factor of E into r. So I've written this electric field, in fact this gravitational field, into distance. This method we can use only when the field is constant, and in this case the field inside the cavity is constant. So we can easily use this concept. So it is 2 by 3 rho r square into g pi. This is delta V, and the work done by gravity would be m delta V. So this is 2 by 3 rho r square g pi into m. Now this work done is in the form of kinetic energy. So let us equate it with kinetic energy. So this is g pi m, cancelling this m with m. So V is equal to root of 4 by 3 rho r square g pi. So V is equal to 2 r under root rho g pi by 3. So the correct option is A. And the next option, which says that the ball will take time t to reach from A to C. Let us examine this also. We know that the acceleration of the ball is equal to I, which is gravitational field intensity, and we have already calculated it as 2 by 3 rho pi rg. So this is 2 by 3 rho pi rg. This is A. Now we already know the velocity, which is 2r under root pi rho g by 3. This is pi rho g by 3, and the time taken by the ball will be v by a. So v by a will be equal to, this is 2r under root pi rho g by 3, and a is 2 by 3 rho pi rg. So cancelling this r with r, this 2 with 2, we can say that the time will be equal to under root of 3 by rho pi g. So the correct option will be option number B also. Now C option says that the acceleration of the ball from A varies with the distance from point O. This is incorrect, because we have already discussed that the acceleration of the ball, which is also called as the gravitational field intensity, inside the cavity is always constant and acting towards the center of the sphere, like that. So this is incorrect option. And the option number 4, which is the weight of the body which is placed at point B decreases by a factor of 7 by 8 due to excavation of this cavity. Let us examine this also. So if this sphere was initially full, complete, and no cavity was excavated, then the intensity of gravity at this point B was rho and r by 3 epsilon naught. So we can again use the analogy. This is electric field, and I can use epsilon naught as 1 upon 4 pi g. So this, let us write it as E. So I1 will be rho r upon 3 into 4 pi g. So this is I1. Now when a cavity is carved in this sphere, then you can see that cavity would be present here some, and the distance of the center of the cavity from this point will be 3r by 2. So we have to find out the intensity of gravitational field due to this cavity at this point, which is at a distance of 3r by 2. Now we know that the density of this cavity is also constant. So I2 will be equal to gm by 3r by 2 whole square. So I2 will be equal to 4gm by 9r square, and m can be written as rho into this is the volume of this will be, the radius of this smaller sphere is r by 2, so its volume would be 4 by 3 pi r cube by 8. So m will be rho pi r cube by 6. Okay. So if I substitute this value here, so this is 4 by 9 g into rho pi r by 6. Okay, what I have done, I have cancelled out r square with r cube. This is 6, this is rho pi, and this is 4 by 9. So I2, you can see that I2 is equal to cancelling this 4 with 6, and it would be 2 by, this is 27 g into rho pi r, and the I1 was this. So if you will divide these two, then let us see that there would be a factor of 9, but in the option number D there is no factor of 9, so this is also wrong. So the correct options are only A and B. Now we move on the next question. In this question, you can see that there is a small positively charged ball B of mass m, which is suspended initially with a rope of length L. Another ball of same mass m and some other charge is moved from infinity, and it is being hinged from this point, and it is moved along this line so that it repels B, and in final stage, in final equilibrium position, B is at an angle of theta, small angle, and it is raised to a height of h from initial position due to the electrostatic repulsion of A. Now, it is also given, it is not mentioned in the question that what are the charges of these two balls, but it is mentioned that mass of ball B is m. Now, in this case it is given that h is very less than L, so we have to assume this assumption. So let us draw first of all the free body diagram, and we can see that the ball A is at this position and ball B is at this position. Now ball A would be pushing this ball B with some force F, and mg would be acting in the downward direction, and tension would be acting like that. Let's suppose this angle is theta, so this length is x, and x would be equal to, this is L and this is L, so you can see that this angle is theta by 2, this one, and this component would be L cos theta by 2, and this x would be equal to 2L sin theta by 2. So x is 2L sin theta by 2. Now you can see that this angle is 90, this is 90, this is 90 minus theta by 2, and this angle is therefore 90 plus theta by 2. Okay, now this angle, you can see that this angle is theta, so this angle would be 180 minus theta. So you can use the sine law, and you can say that mg upon sine 90 plus theta by 2 is equal to f upon sine 180 minus theta. So you can say that f is mg sine theta upon cos theta by 2. So therefore this is 2 mg sine theta by 2. This is f. Now we know that F is the electrostatic repulsion force, so it would be K Q1 Q2 by x square, and that would be 2 mg sine theta by 2, and the interaction energy of these two charges would be K Q1 Q2 by x. So K Q1 Q2 by x from this equation will be 2 mg sin theta by 2 into x. So this is equal to 2 mg sin theta by 2 into x. Now x we already know that x is equal to 2L sin theta by 2. So this is 2L sin theta by 2. So let us substitute the value of x, and therefore it would be 4 mgl sin square theta by 2. Now we know that in this diagram, let us draw the diagram again. This is the case that in this diagram, this is h, and h is equal to L minus L cos theta. So h is equal to L 1 minus cos theta, and therefore h is equal to 2L into sine square theta by 2. So I am substituting the value of 2L sine square theta by 2 as h. So the interaction energy will be 2 mgh. So the option number 1, which says that the electrostatic energy of this system is 2 mgh, is correct. Now the work done in bringing this ball from infinity to this configuration would be, so the total work done would be the change in interaction energy of these charges as well as work done against gravity in raising that mass to a height h. So delta U, we know that now U is 2 mgh, and initially when the separation was infinity, U was 0. So delta U is 2 mgh, so work done would be 3 mgh. So option B is incorrect, option C is correct. And you can see that option number D says that the work done in assembling this system is independent on the magnitude of the charges. This is absolutely correct, because you can see that the total work done does not have any term of charges. So whatsoever be the value of Q1 and Q2, the total work done would be 3 mgh. So D option is also correct. So the correct options are A, C and D. Thank you. In this question, you can see that there is a system in which there is a rope which is hanging from roof, and there is a mass M which is hanging on the bottom of the rope. The rope has a mass of L, mass of M and length L, and there is a transverse wave which is being initiated at the bottom of the rope. Now we have to choose the correct option from the following 4 options. So let us first of all find out the time which this pulse would take to reach the top. So we know that the tension at any point on this rope, at this point let's suppose, which is at a height of x, would be m by L into x plus mg. You can easily find out this tension by using unitary method, and this is the tension at this point. Now velocity of the wave at this point would be under root t by mu, and v wave would be equal to mx by L plus m g divided by mu, where mu is the mass per unit length and it would be m by L. So v wave will be equal to under root of x plus ml by m into g. Now v wave can be written as dx by dt, and it is equal to under root of x plus ml by m into g. You can write it as dx upon under root of x plus ml by m into g, and it is equal to dt. Now, integrating both the sides, you can see that we can apply the limits here 0 to L and here 0 to t, where t is the time in which the wave will reach the upper end. Now integrating that side, so this is dx upon 0 to L dx upon under root of x plus, this is ml by m, and this is g, and it is equal to integration 0 to t. So let us apply the limits and let us integrate first. So it would be 2 under root of x plus ml by m divided by g, and the limits would be from 0 to L and it would be t. So you can see that we can apply the limits, and it would be 2 by root g, and when I substitute the limit L here, then it would be ml plus ml by m under root minus, I'll put the 0, then it would be under root of ml by m. This is t. Now we can take this root m common in the denominator, and it would be mg, and you can write it down as under root of ml plus ml minus root m, and you can also take out L common, root L common, so it would be 2 under root L by mg into root of m plus m minus root of m. This is the time. So you can see that option number 1 is correct. Okay, now if m is very less than m, it is given in the question, so you can apply the binomial theorem and you can take out root m common, so it would be ml by mg, and applying binomial you can see that it would be root of m by m plus 1 minus 1, and this is t, and therefore 2 root of ml by mg, and this is 1 plus 2 m by m minus 1 is equal to t. Cancelling this 1 with 1, so t will be equal to 2 under root of ml by mg. Now this 2, in fact, you can see that there would be a half. This would be half because power is half. So this 2 will be cancelled out, and therefore option number B is also correct. Now if m is 0, the time would be this. So let us check that if m is 0, you can substitute m as 0 here. Then there will be a difference of 2, which is not given in the question. So C is incorrect, and the time taken by the wave to travel in the lower half of the rope will be less than the time to travel in the upper half. In fact, this is wrong statement because you can imagine that the velocity, the tension in the upper half, this is upper half, so the tension in this region would be greater than the tension in this region. So T1 will be greater than T2, and therefore velocity in this region would be greater than V2. So V1 will be greater than V2. So we can say that the wave will travel faster in upper half, and therefore the time taken by the wave to travel in upper half would be lesser. So statement D is also incorrect. So the only options which are correct in this questions are A and B. Now we move on the next question. In this question, you can see that there is a long solenoid which has 1000 turns per unit length, and a current of 1 ampere is flowing through that solenoid. It has a soft iron core of relative permeability 1000, and this core is heated beyond the Curie's temperature. So we know that iron is a ferromagnetic material, and obviously we know that for ferromagnetic materials, this is mu r, which is 1000, and for a paramagnetic material, we know that paramagnetic material has a mu which is approximately between 1 and 2. So let us assume that it is 2. Okay, so we see that as soon as the temperature is it is heated beyond the Curie's temperature, this ferromagnetic material will behave like a paramagnetic, and we know that B is equal to mu naught into mu r into Ni. So this is B is equal to, this is mu into Ni, and H magnetizing field is B by mu, so it is Ni. So you can see that magnetizing field is independent of the mu, hence it is independent of the medium of the core, therefore it will remain unchanged, but B will decrease drastically. So option number A is correct. Option B is that H and B are the fields in the solenoid and remains nearly unchanged. This is wrong. The magnetization of the core reverses the direction. This is also incorrect because there is no diamagnetism. In fact, ferromagnetism and paramagnetism has only the difference of strength of magnetism, and the magnetism in both of them is in same direction. So core will not have a opposite magnetism. So C is also incorrect. And the D is the fact that magnetization in the core is diminished by a factor of 10 to the power 8. This you can this is a factual point which we should know, that the difference of magnetization between a ferromagnetic and a paramagnetic material is of order of approximately 10 raised to power 8. So we can by factual knowledge we can say that option number D is also the correct one. So now we move on the next question. In this question, you can see that there is a thin, infinitely long metal sheet. This is a metal sheet whose length in this direction is infinity, and its breadth is B. This width is B. This is the front view of the metal sheet, and current is flowing like that. And there is a magnetic field which is parallel to the plane of the sheet, but this magnetic field is perpendicular to the current. If I will show you the cross section view of this sheet, then it would be like that. These cross represents the direction of current flowing in the sheet, and there is a magnetic field in this direction perpendicular to the direction of flow of current, B. So we have to find out first of all a mechanical pressure acting on the plate. So let us first of all assume that there is a element, there is a small element like that in this sheet. This is the element, and its width is dx. This is a small width dx. I can say that from the complete width B, the current flowing is I, and from the unit width, the current would be I by B. And from this width dx, the current flowing di will be I by B into dx. This is the unitary method. And I can assume that this is an infinitely long current carrying wire, and therefore if I find out the force acting on this wire, then that force will be I is the current, L is its length, which is infinity obviously. So let us find out the force on some part of this wire which is of length L. So let us assume that this length is L, and we are finding out the force on this length only. So this is I, and I is di, because di current is flowing through this wire, and L is its length, and B is the magnetic field. So F is equal to di, which is I by B into dx into L and into magnetic field. And you can see that this is area. This is area of this strip, and therefore the pressure would be force upon area dA, and it would be I B by B. So this is the pressure. So option number A is correct. Now option number B, that when the direction of magnetic field is reversed, in fact the direction of current is reversed, then the direction of pressure does not changes. This is wrong, because as the direction of current will be reversed, the direction of force will be reversed, and therefore the direction of pressure will be reversed. In the third C part, it is given that in the case of external magnetic field, when it is switched off, then a magnetic field of mu naught I by 2b is observed parallel to the plane of the sheet but perpendicular to the direction of current. We all know that let us take a new page. Let us draw this cross section of the sheet again, and you can see that current is flowing like that. We all know that if this is the width of the sheet, then the magnetic field on the upper part will be like that, and the magnetic field in the lower part will be like that, and this would be constant, and it would be equal to mu naught K by 2, where K is the current per unit length. Okay, so this is current per unit length. So you can see that this k in this case is I by b. So b will be equal to mu naught I by 2b. So the correct option is option number C, and therefore option number D is wrong. So the correct answers are option A and C. Thank you.